Hi guys, so good day. I'm Haro J. Papaya and I'm the new instructor of Cebu Technological University Danao campus. So today we um, talking about how important the machine elements in terms of designing in machine and any kind of any kind of mechanism. Okay, so let us start. So machine elements 1. Graphical and analytical approach. So machine elements 1 is very important to our engineering application. So nowadays, tanang mga designing sa mga structural members or mga mechanism sa machine is through mga specification na lang or what we call kanang uh, through specification na lang and through input na lang sa computer and pag simulate na lang ingana. So today kana siya dili na nato di na nato ma-appreciate tungod kay mag input na naman ta sa iyang data, so di nato wala nato wala nato i-consider ang iyang possible movement. So kabaw ta sa mechanism is mag mag-deals gyud na og kuan kana oscillating members. That oscillation is makakos na og fatigue stress. So dapat kana ato sa nang i-consider. So sa kani nga machine elements mao gini ang importante sa pag-design sa mga machine. Okay? So let's have an overview muna. So first is introduction of the concept of kinematics machineries. And dua is vector, operation, and analytical and graphical method. And nakatlo is motion and machinery. And next is instant center, location of instant center. Then next is velocity and acceleration analysis. Next is cam and follower, rolling bodies in pure contact, and gears and gear train. Lastly is belts and pulleys, chain, flexibles, connection, step, step, pulleys. Okay? So, let us focus lang sa kaning introduction of the concept and of kinematic machineries. So, introduction of kinematic machineries. So, kinematics is the study of relative motion and geometric relationship of machine parts without consideration of forces. So, kinematics is the branch of mechanics that studies aspects of rigid body motions that are independent of both forces and times. So, sa atong dynamics, so ang iyahang definition sa kinematics is di tama consider sa iyahang forces. Okay? So, only motion ra. So, kinetics is diya na mag-consider na ta sa iyang forces and the time. So, kana. So, kani nga method is mo ni ang gamito nato to design all the movement of the mechanism. Next is machine. So, machine is a device designed and used to transmit power of force and transform motion from a source input to a useful application. So, the term machine is usually applied to a complete product like our car is a machine, as is a tractor, machine, and a combine and earth moving, it is a machine, or etc. At the same time, each of these machines may have some devices performing specific function like windshield. So, unsay mga function ana like mo oscillate siya no or magbalik-balik nga movement. Windshield wiper in a car, which one called mechanism. So, ang usa ka machine di na siya matawag og machine kung wala siya mechanism. In that mechanism, we have input link, or that input member has a continuous rotation that transmit into rectilinear motion, or what we call sliding motion ba. So yan na. So observe this backhoe. So this kaning arm sa iyang backhoe naani kanang input link, which are mo magpadagan sa atong arm sa atong backhoe. Nani input link nga maka continuous rotation and makakusa pag move sa iyahang backhoe. Okay? So let's move to mechanism. Mechanism are assembly of linkages that are designed to produce constrained motion in mechanism. One link is fixed, and the fixed link is also known as the frame, or we call it sad nga structure. Then the input, so mo ta ingon, the input mechanism have a continuous rotation, then transform into rectilinear motion. So kani not example. So as we observe, this kanang internal combustion engine. So kaning crank mo ni ato ang input link, or mo ni ang continuous rotation nato. Ug ang kaniyang piston or connecting rod mo ni iyang follower nga mo transmit into movement sa iyang cylinder head. So mo na nga example sa mechanism. Okay. So next, move to kinematic diagram. So in kinematic diagram is a simplified scale drawing of machine parts wherein only the dimension that affects the relative motion is considered. So kinematic diagram shows only the dimensions that affects its kinematics. So the only geometric feature, either this figure, only the connecting rod or the piston, only important to the kinematics of the mechanism. So if we design a mechanism, so dili tanang features sa usa ka machine ato ang i-considered. So mo choose lang tag usa ka ba kanang less nga features like dimensions ra sa kanang ihang length, or the possible movement of the mechanism mo ra to considered. So we have link. So a link is a rigid body that is connected to other similar bodies to form kinematic pair. So ang usa ka mechanism di siya matawag mechanism kung wala siya mga link or mga structural members that is connected to other members. Okay? And natay look at type sa link. So we have this. So this binary link connects to other link, and this ternary link connects three other links, and this quaternary link connects four other link. So mo na yung mga klase-klase nga link nga pwede sa ato ang mechanism. And we have kinematic pairs. So, kinematic pairs, the two bodies in contact that are joined in such way that our relative motion between them is possible, is called the kinematic pair. So, kinematic pair when two links or elements in machine are in contact with each other, they form a pair. So, kung usa ka duha ka member or ang duha ka element kung dili mag-contact, so kana di na siya matawag og pair. When the relative motion between these two links is completely partially constrained, then the links are said to form a kinematic pair. So as you observe this kinematic combustion engine nato, so kaning ato ang cylinder head and the cylinder cylinder block is nag-contact sila sa usag-usa. So kani nga member, so kana is matawag na nato og kinematic pairs because nasad sila'y relative motion sa usag-usa. Okay? So we have a classification set of kinematic pairs. So una is ang lower pair. So lower pair when two surfaces area are in contact in piston head or like this and piston head in contact with the cylinder head wall. So kana siya matawag na og lower pair. So ang iyang duha ka surface area nag contact usab usa. And ikaduha is a higher pair. So higher pair when the contact exists at a point or a line. So observe this figure. A cam and contact with the follower is a example of the higher pair. So at the point of contact sa kaning cam o iyahang support head ani, so mo na gitawag og higher pair. So nga na ang case. And then we have a wrapping pair. So wrapping pair, it's a wrapping pair when the contact forms a complete wrapping. Example sa kaning belt and uh, pulley. We have driving pulley and driven pulley. So kani nalukop gid siya sa kaning belt. So kana matawag na siya og wrapping pair. So we have kinematic chain. So a kinematic chain is an interconnected system of link in which not a single link is fixed. Such a chain becomes a mechanism when one of the links in the chain is fixed. So the fixed link is called a frame or sometimes a base link. So for example, kani the this mechanism crank and follower. So if ever mawa ni ang iyang hinge or gitawag nato og fixed link and we replace into another link lang na i-connect nato into revolute pair. So ang kana matawag na siya og kinematic chain. So wala na siya ay fixed link. Okay? So we have types of lower pair pod. We have revolute pair or turning pair. So, sa revolute pair is or turning pair. So when one link can rotate or relative to another link. So the degree of freedom. So what do you mean of revolute pair is 1. So what do you mean degree of freedom? It is um, approximation or number of movements sa usa ka mechanism or the parameters of the variables of kanang movement sa usa ka mechanism. And then we have prismatic pair or sliding pair. And then katulo is screw pair, kaupat is cylindrical pair, and ikalima is spherical pair or globular pair. Okay? So sa kaning klase-klase nga pair nasad na sila yung mga tagsa-tagsa pud nga degree of freedom. It depends kung naka-fix ba siya ang iyang ang mga link niya or wala. So it depends sa iyang link. And then we have planar mechanism. So sa planar mechanism, it's one in which all points moves in parallel planes. A joint between two links restrict the relative motion between these links, thus imposing a constraining condition on the mechanism motions. So we have our requirements for planar mechanism. So first is all points in the mechanism should remain in one plane. So it is a basic nga figure nga sa pag-design nato. So ikaduha is the axis of all revolute pairs must be parallel and perpendicular to the plane of motions. So kana og di ta mo obey sa iyang requirements, so di na siya matawag og planar mechanism. So unsay matawag ana? It is called the spatial mechanism. So spatial planar mechanisms are two-dimensional ra in nature, while spatial mechanism are three-dimensional. So sa planar is in terms of two-dimensional or 2D ra ang makita nato sa atong figure. And a spatial mechanism is three-dimensional, which is daghan nato consider sa movement niya. So para sa aning crank and follower mechanism, so atong matan-aw dia is two-dimensional na siya. Okay? So let us move into the topic of Gruebler's criterion and degrees of freedom. So the goal of this section is to develop Gruebler's criterion or Gruebler's criterion calculates the theoretical numbers of degrees of freedom within a mechanism, which is also known as the mechanism F number. So the degree of freedom, or also known as a degree of mobility, is used to define a number of parameters or variables to describe the overall movement of all the links in the mechanism. So, dira na to ma-describe kung unsay kanang parameter sa usa ka parameter sa movement sa usa ka mechanism nato. So, according to Gruebler's criterion, the theoretical numbers of degrees of freedom in mechanism is given by kana ay so degrees of freedoms is equals to 3n minus 1 minus 2g minus h, where n is the number of links nato in the in the mechanism in which one is a fixed link, and the g is the number of lower pairs, and the h is mo na to ang higher pair. Okay? Let's have an example para masabtan gyud nato pag-ayo. For example, this crank and follower mechanism. So, as you observe, so naa say duha ka pila ka link. So i-describe na to ang unsa to nga formula. So DOF is equals to 3n minus 1 minus 2g minus h. Okay? So in this mechanism, pila ang iyahang link? We have 1, 2, 3, and the 4, which is the fixed link. So makita makakita ka gani og hinge or kani nga fix nga hinge is as counted na as 1 na siya. So we have n is equals to 4 links. In the lower pair, so we have this kind is a revolute pair sa hinge. In this, connected to the input link in the followers is revolute pair gihapon. So 1, 2, 3, and 4. So ang iyahang lower pair is 4. 4 pair. And then the higher pair is 0. So wala tay nakita nga point of contact sa usag-usa. Okay? So ang higher pair niya is equals to 0. So the degrees of freedom is equals to 3 minus 4 minus 1 minus 2 times 4 minus 0. So the degrees of freedom is equals to 3 times. So 4 minus 1 is equals to 3. And 2 times 4 is 8. So degrees of freedom is equals to 9 minus 8. So degrees of freedom na to is equals to 1. So the degree of mobility or the parameters of the movement of this mechanism is equal to 1. Okay? So let's have an example number 2. So example number 2, we have 1, 2, and 3 links. So 3 links. So sa tatong formula sa degrees of freedom. So degrees of freedom is equals to 3 times n minus 1 minus 2g minus h. So the degrees of freedom is equals to 3 and the number of links sa kaning nga mechanism is 1, 2, and 3. So 3 minus 1 minus 2 times number of pairs or lower pairs is pila. So 1, 2, and 3. So 3. And higher pairs, so what tayo nakita nga point of contact niya sa kanang nga figure. So ang h niya is equals to 0. So degrees of freedom is equals to 3 times 3 minus 1 is 2, and then minus 2 times 3. So the degrees of freedom is equals to 6 minus 6 or equals to 0. So modify nato kung unsay parameter sa iyang movement sa usa ka mechanism niya. Okay? So example number 3. So this mechanism is called unsa ni siya? Slider and crank mechanism. So sa slider crank mechanism, so ato sa define or ito what ang degree formula sa degrees of freedom. So the degrees of freedoms we have 3 n minus 1 minus 2g minus h, and then the degrees of freedom is equals to, so the number of links is pila 1, 2, and 3, and then the length of the ground, so we have 4. So this slider is considered as a link nato into the ground. So we have 1, 2, 3, 4 of number of links. So number of links is equals to 4. And then the lower pairs we have 1 kani, it is a revolute pair, and then kani it is a revolute pair, and kini is it is a revolute pair. So pila? So 1, 2, and 3. Isa pa'y mga kuan. And napod prismatic pair. Types of lower pair is prismatic pair. So 1, 2, 3, and 4. So prismatic pair, or we call it sliding pair. So we have lower pair is equals to 4. So now substitute n is equals to 4 minus 1, and 2 times 4 minus, so dire ang point of contact niya is wala sa kaninga figure of mechanism. So ang iyang higher pair is h is equals to 0. So degrees of freedom is equals to 3 times 4 minus 1, 3 minus 2 times 4 is equals to 8, or degrees of freedom nato is 9 minus 8, or degrees of freedom nato is equals to 1. Okay? So, last example. We have come and follower mechanism. So, sa come and follower mechanism, pila ato ang link ani? So, we have link A. So, kani, or ang iyang crank, and then or ang kani, and then the link B is kani, and then the link C is kani, and the follower, or kani nga link C is we called it a roller. In this link D is we called it a follower. Okay? So, pila tanan? 1, 2, 3, 4. So, the number of link nato is 4. So, ato ikuha ng degrees of freedom nato. Ang formula. We have 3 times n minus 1 minus 2g minus h. So, where n is equals to 4. So, the lower pair, pila man? We have revolute pair A and revolute pair C. And then, at D, which is the prismatic pair, or we call it a sliding pair sa kani. Diba? Slide in this duha ka member, kani nga contact. So, we have a sliding pair. So, tanang lower pair is equals to 3. So, G is equals to 3. And then, we have a higher pair. So, asa man dapit ang iyang point of contact. So, kani nga portion no, at point C. So, this point of contact, digid sila or most stay together siya sa kaning roller at and this crank. So, na sila point of contact, or we called it the higher pair. So, we have H is equals to 1. So, the degrees of freedom is equals to 3 times 4 minus 1 minus 2 times 3 minus 1. Then the degrees of freedom is equals to 3 times 3 minus 2 times 3, 6 minus 1, or degrees of freedom is equals to 9 minus 6 minus 1, or the degrees of freedom is equals to 2. So, this mechanism have a true 2, or the parameters of the movement of the mechanism. So, na siya duha ka degrees of freedom. Okay, that's all. Thank you.